Mystery Science and Math, an all-in-one introductory lesson on energy by Jeannine Haxton and Theresa O'Leary.
This presentation is for teachers from kindergarten through 5th grade. Our model lesson was given to 2 4th grade classes of 34.
We want to show how you can integrate math and science, which shows the first lesson in the unit, Energizing Everything. This lesson is called How a Car Can Run Without Gas.
The science and engineering practices used in this activity are SEP3, the students carry out an investigation, and SEP4, the students analyze and interpret data. For SEP3, the students build rubber band racers and use them to examine the relationship between stored energy and motion. They work in pairs and as a class to produce data and create a basis for their evidence. In SEP4, they are engineers. They modify their racers based on logical reasoning, mathematics, and/or computation.
The math practices that we will use during this experiment are MP1, make sense of problems and persevere in solving them. MP2, reason abstractly and quantitatively. MP5, use appropriate tools strategically. MP6, attend to precision. MP7, look for and make sense of structure. MP8, look for and express regularity in repeated reasoning.
The intersection of science and engineering practices and the math practices occur with SEP3 when the students carry out an investigation in order to inquire about stored energy. The math practices are MP1, make sense of problems and persevere in solving them. MP5, use appropriate tools strategically, and MP7, look for and make sense of structure.
The second intersection of science and engineering practices and math practices is with SEP4, when students analyze and interpret their data. They will be using MP2, reason abstractly and quantitatively, MP6, attend to precision, and MP8, look for and express regularity in repeated reasoning.
The science standards used in this lesson are: first, the students use evidence to construct an explanation relating to the speed of an object, to the energy of that object, and then they apply scientific ideas to design, test, and refine a device that converts energy from one form to another. Ultimately, we want the kids to think when something is moving, it has energy, and moving things get their energy from stored energy, and energy can be stored in different ways, such as gasoline, batteries, or food.
When content areas connect, you get more bang for your buck. Students explore how energy can be stored and released using a rubber band. The amount of energy that is put into the system is related to the amount of energy that is released. These math standards occur during the experiment when the students are measuring the distance their cars go in inches and then convert them to feet. Later, they take this data and represent it in a bar graph.
This is an optional 2 to 4 day lesson plan. In day 1, you could do a science talk. We had a PowerPoint where we showed the students pictures of objects placed in such a way that if they moved or were moved, something interesting would happen. Then we would show the exploration activity for Mystery Science, which is, can a car run without gas? In day 2, that's the time where the students get to create the rubber band racers, practice using them, modify them based on how well they are working or not working, and then race them as a class. On day 3, the students are able to take the data collected from day 2 and design a bar graph. This could be made more simple by having the students have a template of a bar graph and then working within that template. And then finally, the last day, the students could work to display and then share out their graphs and some of the things they found as they were racing.
On day 1, you will need Notice and Wonder pictures that are not provided by Mystery Science and the Mystery Science lesson exploration. On day 2, you will need rubber band racers and a revised data sheet. On day 3, you will need data sheets, rulers, felt pens, colored pencils, construction paper, glue, and scissors. On day 4, there will be no supplies needed.
Constructing racers. This student exploration was both fun and challenging. The students were first to construct their racers using the materials provided. Then they were to practice using their racers with each other or in pairs, and then make revisions to the racers based on their findings.
Files and data recording. The students bring their cars to a track that is 10 feet long with a sweet spot between 8 and 10 feet. The students will be testing their cars for accuracy, not distance, during this phase. Each time a student comes up to test their car, the other students in the class will tell them whether they need more or less energy.
Interpreting data. On day 3, the students use their data collection sheets to create a bar graph. They take the number of lines and use the number of feet or inches to create these graphs.
Reflections and sharing. After the experiment was over, the students came together and they shared their ideas about what they thought went right and what they thought went wrong. In the beginning, they talked about when there was too much energy. When there was too much energy, sometimes the car turned to the side or went backward or went too far. When there was not enough energy, the car didn't go far enough, probably needed more twists, or the rubber band stuck to itself and didn't allow the energy to release. Other issues were the carpet had too much friction and the wheels were wobbly. Solutions. Some of the solutions the students came up with were they could butter, oil, powder, or put lotion on the rubber band to keep it from sticking to itself. They could have 4 mini wheels instead of 2 giant wheels. They could stabilize the wheels to keep them from being wobbly. They could have a smoother floor surface to help the cars go faster.
Thanks for watching.
We hope you feel inspired.